Muted. Muted.
Good. Joe.
I want to welcome you to the results presentation of the effectiveness of asphalt penetrating sealers and extending new asphalt pavement, sponsored by the Ohio Department of Transportation. It was completed by Applied Research Associates and Harold Von Quintus. It was sponsored out of District 7. Rob Cummins originally was the sponsor, and then he retired, but District 7 still took it on, and now you're going to be here to witness the results. We have this on webinar. We have a lot of people that are on webinar, so please be sure to keep your phones muted. We will ask questions at the end. We will allow Harold to go through his presentation, and then we'll do a question and answer after his presentation. With that, I'm going to give it to you.
Okay. Thank you, Jill. It's a pleasure to be here this morning, and I'm going to try to stand over here where the mic is so it gets over the webinar. So this is a project. This is our final review session. The report has been submitted. The presentation is going to be 5 different items this morning. First of all, it's an introduction and basically an overview for those that weren't directly involved in the project at the beginning. Kind of just a quick overview of some specific items. Then we'll look at an overview of the projects that were used in District 7, called at the beginning. And then we'll look at the individual test section performance, what items were monitored, what data was collected. And then we'll go through some data comparisons and observations. And then we'll end with our summary in terms of findings and recommendations. So basically, this is just when the project started, when it was completed. It was completed at the end of last year, project number, that type of thing. What were the objectives? Basically, the objective was to answer this question that was asked by ODOT, are penetrating sealers cost effective? And so we were really after an answer to that question. Some of the goals that were done in order to get at that objective was, first of all, determine if penetrating sealers extend the service life of asphalt concrete pavements and or wearing surfaces. And if that service life is extended, if we're getting additional service life by using them, does the added service life offset the added cost? And then if that cost is offset, in other words, if they are cost effective, then we were to look at preparing some recommendations on applying those sealers basically to achieve the greatest benefit or best value to ODOT. This just lists a summary of 8 items of the task activities that were used during the project. I'll get into the details of each one as we go through the presentation this morning. The outcomes and deliverables, basically there were 2 final outcomes, a final research report, and then a fact sheet that were prepared. There were other deliverables during the course of the project, like interim task reports, but all those were incorporated either directly or in summary form in the research report itself. And I think Jill said that the fact sheets are available and might be handed out to this morning to those.
At the end of the presentation, we'll hand you out their one-pager. They give you the synopsis of the findings in one page.
Okay. All right. So first now, that was introduction. Now moving to an overview of the project. And I'm going to go through some of these slides reasonably quick because I want to spend more time basically on the test section performance and then our data comparison and observations. But this is just kind of a reminder for those that have been involved in the project previously on what was done, where the projects were, and that type of thing. So we had 3 sealers or suppliers that were involved, as shown here, the BioRestore, the Replay, and the Reclamite. There were test sections, multiple test sections set up at each project, including those. And obviously we had on each of the individual projects, we had a control section. So we had control sections and then sections with each of the sealers. On the bio-restore, kind of shown here in the upper right, as well as the replay, basically that was a single-step process where the sealers were placed on the surface. And on the Reclamite sections, that was more, I guess, what we call, or what we've referred to as a multi-step process in applying the sealers. And the multi-step process was basically laying down or spraying the Reclamite to the pavement surface, and then putting sand down, and then basically sweeping it up after it's been down there a while. Excuse me. As we get into the test sections themselves and looking at some of the performance observations, I'll come back to this part right here a little later. But kind of keep in mind that the Reclamite's a multi-step process. The other two was more of a single-step process in terms of spraying the sealer to the pavement surface. We had 4 projects that Rob originally set up and identified. One was on US 40. There were 2 on State Route 292, but they were in different locations. We referred to those as Location A and then Location B, and then the one on State Route 47. All were asphalt concrete overlays. US 40 had an existing jointed plane, jointed plane or jointed reinforced concrete pavement. And the other 3 were asphalt concrete overlays, more of a mill and fill. The US 40 did have an existing asphalt concrete surface, so we were not placing, or the contractors were not placing, the overlay directly on the jointed concrete pavement surface. It had previously been overlaid. So we have a very mixed range of conditions. US 40 had relatively high traffic, more in kind of an urban area. The SR 292 projects would be considered low traffic volumes. One was on the Location B was an extremely low traffic. And then SR 47 had multiple intersections in a urban environment, and also had a lot of turning movements, which I'll get into later also. So right now I'm just going to kind of quickly go through each one and just show some visual images of each project. US 40 was the first project that was done. It was near Springfield, Ohio, and it's a 4-lane urban roadway. Both sections are in all lanes in each direction were used. Our test sections were in the outside lane, however. We monitored basically both lanes, the traffic and as well as the passing lane, but all the test results that we did, all the data collected, the permeability, the sand patch test, all that was, and density tests were all on the outside lane in both directions. And this just shows where the sections are located. I think on the westbound, it was a control section, then the bio-restore, the replay, and the Reclamite. In the eastbound direction, it was the same, but in the opposite control, bio-restore, then the replay, and then the Reclamite. For all of these sections, there was a transition area that varied in length between each of the test sections, or where the sealers were applied, as well as for the controlled section. So transitions between each one in applying the sealers. This is Project 2. It's in in East Liberty, Ohio. I think that would be kind of on the southwest part of East Liberty. It's adjacent to 33, if I remember correctly. It is a 2-lane, more rural roadway. The test sections here, the ones where I say test sections, both directions or lanes in each direction were where the sealers were applied. and we monitored, or did, I keep hitting the wrong button. We did most of our testing. We monitored both lanes, but all the test section data came from, I believe, in the westbound direction. And those, since they were sprayed all the way across the roadway, then each individual sealer is in the same location. So the initial one was Reclamite, then Replay, then the Control, and then the Bio Restore. The Project 3 was on State Route 292, called that Location B, also near East Liberty, except this section was kind of, I believe, on the north of East Liberty, or kind of northwest as you go out of the town. This would be a 2-lane rural roadway out basically in the farmland. And again, just like for Location B, sealers were applied in both lanes. And our test data initially was in the northbound lane where the density test and permeability and everything was measured, at least at the beginning. And this shows, again, we had our control section was initially, followed by the Reclamite, then the Bio Restore, and the Replay. And Rob originally, when we arrived at the project, Rob had already coordinated with each of the suppliers and had originally set up the test sections where the projects were selected by District 7, and the location of the individual sealers were also, in terms of where they fell on the project, were also established by District 7 and/or coordination with the pavement section. But they were already set up, and then we just basically followed originally their experimental plan. Okay, Project 4 is on SOR 47 in Sidney, Ohio, just going west of the town. It is a 4-lane urban roadway with left turn lanes and some right turn lanes. So it has a lot of turning movements, pretty high traffic, and the sealers, again, were applied all across the pavement or roadway. But again, like US 40, we only did the original testing on the outside traffic lane in terms of the densities that we collect, the permeability, the sand patch test, and that information. But we monitored all of the traffic lanes, inside, outside lanes, over time. And so this one basically had the control initially, then the Bio Restore. Then there was a pretty good distance because there was a major intersection between the Bio Restore and the Replay for that intersection to kind of get away from a lot of the heavy turning movements. And then the Replay section followed by the Reclamite. We went from on this section, and I think you'll see it in some of the photographs that follow. On the eastern end, there were a lot more turning movements, a lot more businesses. And then as we get toward the west end, that's where there were fewer businesses, fewer turning movements. Okay. I put this in, this is in the report, but just kind of get an idea of the AC mixture properties in terms of the mix design, to show that that there are differences between some of the mixes and there are similarities. Probably the key is for our projects on the US 40 and the 2 projects on State Route 292, those were all a 9.5 nominal maximum size aggregate, or 9.5 millimeter type mixes, designed, I believe, with SuperPave or in accordance with SuperPave. I've shown the gradations. The US 40 was a mix 446 type A. The 292 was a 448E type 1. And you can see that the total asphalt content was about the same. All these projects had RAP, and the design error boards were relatively similar for each one. Couple things to note, even though the US 40 project and the State Route 292 locations A and B If you look down toward the finer sieves or the smaller sieves, you'll see a little bit difference where the US 40 project was a little bit finer, even though the same nominal maximum aggregate size. I don't think that had any effect or impact. Just to note it was a little bit finer mix. Conversely, on State Route 47, it was a 12.5 millimeter mix. The big difference, or one of the differences between State Route 47 and the other three project locations, is the PG grade of the asphalt. And where we have a lot more traffic, a lot more turning movements, a PG, in terms of the asphalt grade, a PG 76 minus 22 was used. On the other projects, the other three projects, a PG 70 minus 22 was used. The other item, since this was a larger nominal maximum aggregate size mix, it is a little bit coarser for some of the larger sieves, but when you get down to the finer sieves, it's basically was relatively similar to the State Route 292 projects. It had about the same in terms of design, had about the same percent passing in terms of the smaller sieves for the finer aggregate. Okay, so this just moves now to some of the field activities that were done during the sealer application. I'll go through each one very briefly. We did do condition surveys before the sealer placement, even though the asphalt concrete overlays had just been placed. The reason for doing that is we wanted to identify whether there were any construction defects, like segregation that we could identify, longitudinal joints, that type of thing. So we did do a condition survey on the controls in each of the test sections prior to sealer application. We also did in-place density tests before as well as after sealer applications. Those in-place density tests were done with a PQI, a non-nuclear density gauge. We also did a field water-based field permeability test both before as well as after sealer application. The sand patch test we did before and after sealer application. And then we monitored the application rates that were applied to each of the test sections. The coring, we did coring after, and I say we did in terms of A4A. I did some coring initially, but the contractors that were involved in placing the asphalt concrete overlays, as well as the district, provided a lot of assistance. In fact, one of the contractors actually did the coring themselves. They did a much faster, better job because they do it every day. So cores were done. The reason we did cores was to basically measure the bulk specific gravity of that core to calibrate the PQI non-nuclear density gauge. So those were basically used for calibration purposes of the non-nuclear density gauge. The department did skid testing. They did the skid testing before sealer application, and then they did it what we called immediately after sealer application, referred to as time zero. And then we did 1 day, or I should say not we, the department did 1 day, 7 days, and 30 days after the sealer application. For the State Route 44.
Yes.
So on the State Route 47, because of the heavy traffic, especially during business hours, the 30 days after sealer application, that was the only one. State Route 47, I think, was the only project where skid values after 30 days were not tested. So we also then did lab tests on the cores to measure the bulk densities and the maximum specific gravities. And that was used, as I said earlier, as an adjustment factor for the non-nuclear density gauge to make sure it's reading in the same. Okay, the sand patch, we did sand patch testing. That was done during sealer application. That was also done periodically within the monitoring period. So sand patches were done initially, as well as over time. You'll see the results later on. Water-based field permeability test. And I'll have some comments about this later on the water-based field permeability test. But also, the permeability test was done during the sealer application as well as throughout the monitoring period also. In-place density test and cores, those were only done during the sealer application. They were not done during the monitoring period. So it's only like at time t equals 0 for the in-place density test and cores. Skid testing, I've already mentioned that in terms of the time, that it was also done, as I said previously, by the department. I will say the department did do two types. They used the smooth tires. They also used the rib-based tires. The data that you're going to see when we start talking over the monitoring period, that is just based on the rib tire data. The smooth tire data is also available, but when we did the comparisons and the analysis, we only did base that on the rib tire. And the reason for doing that, that's the majority of the agencies around the U.S. that have specifications, or not specifications, but criteria for skid values. Probably 90%, 80 to 90% are all based on using the rib tire. So that's the reason we focused on the rib tire. If we would have used the smooth tire data that was also collected by the department, it would not have changed the results. So everything kind of moved down or up depending on what type of tire was used for the skid testing. Okay, the other thing is we monitored the sealer application rates. We put out these 1-foot square pads as shown here, and then removed them after the sealers and measured the residual rate of the sealers, calculated the average application rate of each one. Okay. This now shows what the average sealer application rates were for each of the suppliers. Also, I should say that the application rates were really, they were defined by the suppliers themselves. During the project, that was already predetermined on what they would apply, and the project really didn't specify or identify what rates were to be applied. That was left to the sealers themselves. I will come back to these rates later on, especially when we start talking about the data analysis of the test results. But this just shows in each of the lanes, again, the US 40, State Route 292, locations A and B, and then the State Route 47. Key thing to note here that you'll see is that the bio restore generally had the lower residual application rates, then followed by the replay material, and then the Reclamite supplier they put down or had the greatest residual application rate placed between all of the projects, and that was all the projects, all the test sections, consistently. Okay, the condition surveys, we also did condition surveys. Condition survey data that's in the report and that we used in terms of the analysis that you'll see later was done by two different procedures. Okay, Ohio, or the department, did their typical standard pavement condition rating system that they do for all of the roadways in Ohio, and that data was provided to us by Eric, and we used that in terms of looking at how not only the distresses changed over time, but the pavement condition rating value that the department calculates. We used that rating, did the calculation to look at what the pavement condition ratings were. We also used, though, the long-term pavement performance distress identification manual for each of the test sections, both initially as well as through each monitoring period. And condition surveys were done basically every year. The data from the long-term pavement performance distress identification manual was used to also, in accordance with how Ohio determines or calculates a pavement condition rating, the data from the LTAP distress identification manual was also used to calculate a PCR for those same test sections. So we had two different PCRs and two different types of distresses, one defined by the Ohio Pavement Condition Rating System and the other by the LTAP Distress Identification Manual. And I'll show you the differences when we start talking about the comparisons. These now show the average test results between the projects, the 4 projects we did, and all the different test results that were done initially and over time. And these show the results prior to sealer application. So these are basically all the control sections and what was measured on the individual test sections, but prior to placing the sealers. And these are the averages between all of the test sections along a specific project that were measured. So permeability, and you're going to see later on, there was a lot of variability in the water-based field permeability test. And you'll see that in some of the graphs that I'll show later on. But this just shows in terms of 10 to the minus 5 centimeters per second from the water-based field permeability test. The test that we used was the NCAT, or the National Center for Asphalt Technology field permeability test that was developed, and that some agencies picked up and have been using on a day-to-day basis. But right now, really, Florida, the Florida DOT was one of the agencies that used field permeability tests on a lot of their projects. But I think they've kind of gotten away from that now, where they do not use water-based field permeability on a lot of their projects. I think because of the variability that's there. But anyway, the State Route 47 had the lowest field permeability on the average, and that's the finer mix. That's the finer mix. And then the State Route 292B had the the US 40 was the finer mix in terms of the larger sieve size, and that had 292. The State Route 47 was the larger nominal maximum aggregate size, but that had the lower field permeability results. State Route 292B, that's in the northern part of East Liberty, in a rural area, kind of through farmland. That had the greatest field permeability of 320 times 10 to the minus 5 centimeters per second. Sand patch, again, SR, and the sand patch, what's shown here is should be macro, not micro depth, macro depth, MACRO, in terms of millimeter. The State Route 47 had the lowest, 0.145, and again, State Route 292B had the highest macro depth measurement. Densities were, reasonably. The US 40 had the lowest density prior to sealer application of about 143 pounds per cubic foot. And then conversely, now the SR 292B had the greatest density, 145 pounds per cubic foot. I will say that these densities reported here do not include the densities that were measured during construction by the department and or the contractor. They're the densities that we measured with the field cores and the non-nuclear density gauges, the PQI. So there are only densities that were measured on site directly before the sealer application. These values do not include the quality control or assurance data that's done typically on projects. And this is the corresponding air voids in percent. Again, the 292B had lower air voids, higher densities, which you kind of expect. The US 40 had the lower density and not the highest air voids, but about the air voids. But they're all still very good. you know, I don't want to say high or low. All these values in terms of original conditions would represent a good material. And these are the skid numbers of the control sections prior to sealer application. And the SR 292B had consistently the lower skid number, the average being 28.6, and then the SR 40 and SR 47 had the higher skid number with more traffic. Okay, so now this is, remember I said we did condition surveys prior to sealer application to try to identify any kind of surface defects or surface conditions that might cause any kind of skew in the results being monitored over time. And we did find some localized segregation. We found even initially hairline reflection cracks shortly after, and these were transverse cracks, but they were reflection cracks that started to occur in the Reclamite section almost immediately prior to the Reclamite going down. And you'll see the reason for that later on. But and we saw also crushed aggregates from the vibratory roller along one of the longitudinal joints where the cold edge was vibrated, and we had some crushed aggregate along there. We also had some crushed aggregate in localized areas where the mix probably cooled down or was at too low of a temperature, and some of the surface aggregate were crushed. But none of these were significant. They were all basically very localized and relatively minor. And so the other thing that we want to point out, we did see, you know, a few areas localized truck-to-truck segregation, but that would not be representative of the entire test section and our project. So overall, we did not see any major defects right after construction that would skew any of the performance results of a project or of an individual test section. So I don't want anybody that there were a lot of defects on this project. They were not. But we wanted to ensure that if there was, that we felt would skew the results, that those were identified initially. But there were none. And none that we would have a problem with and would be concerned that that's going to skew our performance results over time. Next, so that's kind of an overview of the project, what was done. And now I'm going to move into the test section performance, some of the values in terms of condition surveys and other values that were done throughout the project in terms of the annual monitoring. This shows now our last survey was done this last summer, around in June, I believe July 2016. These are going to show some photographs of each of the test sections that are representative of all the project and or individual test sections. And so US 40, and these are the control sections. But if you, on the average, basically in terms of what types of distress that were there, what severity levels, basically they're the same between the control and the treated sections. This is US 40 for the control. That's an asphalt overlay of jointed concrete pavement, and as what you might expect, reflection cracks, transverse cracks, reflection cracks from the joints in the underlying asphalt jointed plain concrete pavement or the predominant distress. And they vary from low severity. There's a lot in the moderate severity. There is even a few in the high severity area. And this just shows typical example of the transverse cracks, which are reflection cracks. This now shows the total length of transverse cracks in terms of feet throughout the section. And you can see that the overlay was placed in 2012. The next year, we started seeing quite a few of the reflection cracks, and as they just continued to go up to about 2014, and then the low severity, what's shown here, the low severity cracks in the dark triangle or circle, those were low severity, And the reason they're starting to level off or increase to some degree is that the moderate severity cracks are starting to increase. So some of the low severity cracks from the previous year have now propagated into a moderate severity crack. There were a few that were also identified as high severity, but I don't have those shown on here. And the moderate severity, that's the open diamond and the open circle. So quite an extensive amount of cracking. This shows now the total length in terms of by the FHWA long-term pavement performance procedure, in terms of the actual length, in terms of feet for each test section, and the different lanes, westbound, eastbound, and so on US 40. And, you know, just to show there's quite a bit of cracking in terms of reflection cracks, which we would have really expect, because this is more like a mill and fill or thin overlay. So the cracks that are there, they're going to reflect through reasonably quick. State Route 292A, this is control section, and this is the section kind of, I guess it was southwest of East Liberty. And the types of cracks we see here, we see some few transverse cracks. Some have been sealed. The longitudinal construction joint also has been sealed. And then we see some area cracking, and then we see some short longitudinal cracks. So this is also an AC overlay of a flexible pavement. And these longitudinal cracks that we're seeing here were, and this is in 2016, summer 2016. We believe these are the kind of early stages of alligator fatigue cracking, early stages of fatigue cracking rather than just longitudinal cracking. And this now shows on 292A the length of longitudinal cracks over time. And this shows that they're also increasing. About 2014, you know, we didn't see many, but in 2015, we started seeing a lot more of those longitudinal cracks. The bottom graph shows the total length of transverse cracks in terms of feet, total feet per individual test section. And you can see the transverse cracks also started to increase. And this, should have mentioned the solid circles are always the control, and then either the cross, the diamond, open diamond, or the X. Those are the individual supplier test sections. And if there's multiple test sections, this is the average for both directions, which there is in all of the projects. So this was representing an average of those test sections. Okay. Okay. So now moving to the State Route 292B control section. This is also, this is up in East Liberty, but kind of on the north, maybe northeast of East Liberty on the north side. You can now see, we're starting to see on this section actual fatigue cracking that has already started to occur. And so what I've shown here, there's two types, predominantly fatigue cracks and longitudinal cracking. The upper graph shows the total area in terms of square feet. So it's in terms of square feet and not percent lane area, but it's square feet measured total fatigue cracks over time. And again, you can see in 2015, we saw a pretty good increase in the area of fatigue cracking, The lower one shows total length of longitudinal cracking for each of the individual sections. Again, like the previous graph, the solid circle or the blue circle are the control section, and then the open diamond, the plus sign, and the X or the cross, that's the individual sealer application rate or test sections. Now moving to State Route 47, the control on June 2016. Again, this is the 4-lane undivided with a left turn lane, as also in some areas with right turn lanes. This now shows the eastbound versus westbound on State Route 47. And this is basically total length of longitudinal cracking. And the length of longitudinal cracking is relatively small. It's not like we were seeing close to 1,000 feet in some of the other sections. So it's generally less than 100 feet within the total test section. So it's not a lot. Well, again, we started seeing some of them in 2014, and then in 2015 started to increase. I would say that even though we showed 2012 here in terms of State Route 47, this on State Route 47, 2013 is when the sealer was actually applied, and then we started taking our annual measurements after 2013. So on State Route 47, the sealers were applied much later after the AC overlay was placed relative to the US 40 project and these two sections on State Route 292. So there's a difference in terms of the initial 3 versus State Route 47, and that there was more traffic applied to the surface prior to the sealer application between 47 and the other projects. What I'm going to do now is just show you some kind of overall results before I get into the comparisons. This is the results of sand patch test in terms of texture depth in terms of millimeters. So the y-axis on each graph is the texture depth in terms of millimeters from the sand patch, and obviously the x-axis is time or year. US 40, upper left hand, shows the increase, really started to increase in about 2016, and that was generally the case for also the 292 sections as well as State Route 47. However, a texture depth of 1 millimeter, even though they're going up, that's not a significant texture depth. That's relatively low. So that doesn't indicate it's going bad. A texture depth of 1 millimeter isn't that really significant, I guess I should say. So they're all still relatively low, even after about 4 years of time. This just shows the field permeability test. You can see from where the sand patch texture depth kind of crunched, about the same, especially when we're looking at the early end. For the field permeability test, that wasn't the case. We saw a lot of difference between test sections, a lot of difference between over time. So there's a lot there, and the field permeability test has significantly a lot higher variability in the results than any of the other tests, as well as our condition surveys that we did over time. So it's the variation is quite extensive. But what you can see, if you kind of look close, there is a general trend with downward in terms of permeability, which we would generally expect. You can see that the permeability between 2, and the field permeability tests were done on an every other year basis, not on a every year basis. So you can see from the initial results, they go down each one, and then between 2014 and 16, they were relatively about the same value on the average. That's the average value. The average values were relatively about the same. But there's a lot of variability in field permeability. So our predominant distresses, the US 40 was transverse cracking. That's the predominant distress. Those transverse cracks are reflection cracks. US 292 A and B, the A was predominant distress. That was near Route 33, adjacent to it. Transverse cracks and longitudinal cracks. And we believe the longitudinal cracks here are really the early stages of the T cracking. On State Route 292B, the predominant distresses were longitudinal cracking and fatigue cracking. And then State Route 47, longitudinal cracking. We're listing that as the predominant distress, but the amount of longitudinal cracks are relatively small on that segment or section of State Route 47. Rutting was minor for all sections, all projects. Very low levels of rutting. Bleeding, no bleeding was noted on any of the test sections. Obviously, no potholes were noted on any of the sections, any projects. We did note some raveling, generally minor, and it was limited to specific projects. But we didn't see it tied to that we could identify back to the areas where we had identified truck-to-truck segregation. It didn't appear to be a one-to-one there, that was truck-to-truck segregation that we identified before the sealers were applied. So they were in generally different areas. But we did see some minor raveling limited to specific projects as well as to specific locations. And it was generally all minor. Now a little bit on comparisons and observations. I'm going to go through each one now, the tests that were done. This is the skid number, and you see the red dashed line on the upper and lower. That's a skid number of 30. And the only reason I put that line, dashed line, red dashed line in was to look at the difference in the skid values between for the treated sections in comparison to the control section. So the x-axis is the skid number on the control section at 0 days, the upper graph. Upper graph, x-axis, skid number, control section at x days. The y-axis is the skid number of the treated sections at 0 days. And what you can see as a skid value of 30, all the treated sections had skid values less than 30, okay? So if you look now at the lower graph, there's also our dashed line, red line of a skid number of 30. And the x-axis is the skid number untreated for the control sections at 30 days. And then the y-axis is skid number for the treated sections at 30 days. And now the important part here, now they're all above a skid number of 30 at 30 days. But you can still see that that the treated sections consistently, all of the treated sections consistently still had skid values or skid numbers lower than for the control section. And I'll come back to this when I talk about some of our findings and those types of things a little bit later. The permeability, you can see there a lot of variability in our field permeability test. The x-axis is the permeability of the control or the untreated section. The y-axis is the permeability of the treated surface. They're generally and initially along along kind of the line of equality. Over time, because this is the last set of field permeability tests, you can start to see that some of the treated sections have maybe consistently a lower field permeability than the control, but we can't really say statistically it's a lower number because of the variability in the data. Okay, those were averages. Texture depth. Texture depth turned out to kind of started to show us a few things. On this graph, x-axis is the texture depth of the untreated sections, and the y-axis is the texture depth of the treated sections. And now for this is also for our last distress survey. You can start seeing now those sections are, no, I said that's incorrect. This is all the data from initially to our last sand patch test in 2016. So initially, when you're after construction, you can see out along the line of quality, which we kind of expect, but then over time you start seeing a little deviation from the control section. In other words, the texture depth of the treated section is consistently a little bit lower than for the control section, as shown in here, for the higher texture depth. So we're starting to see a little bit difference within the 4-year monitoring period. This is now the PCR data. Now we took the distresses for the Ohio using the Ohio distress surveys. We also took the distresses from the long-term pavement performance, and we calculated the PCR values in accordance with ODOT's procedure. And the y-axis, or excuse me, the x-axis shows the PCR of the Ohio distress surveys for the untreated, and then the y-axis is the PCR value using the distresses from the Ohio-based distress surveys. And you can see that for the treated sections that were, as we get over time to lower PCR values for the untreated sections or for the control sections, that some of the treated sections have a little bit higher, on the average, a little bit higher PCR value, indicating a little bit less distress. This now shows the LTAP, long-term pavement performance survey. Basically, it shows the same thing that the Ohio-based distress surveys in terms of PCR show. So, and you can see there's quite a bit of variability for both, for the individual test sections. Now, coming back, we also, when we started looking at the data, we started looking at, in terms of the test, field permeability versus air voids, macro depth or texture depth versus permeability air voids. And initially, it was kind of all over the place. But one thing that we did see consistently, and this comes back to what I noted about the difference on State Route 47. If you look at this first on the open circles, other projects, there's a reasonable correlation on the average between the HMA density and the field permeability test after sealer application, kind of time zero, right after sealer application. There's a reasonable correlation there. And what kind of threw us initially is because we had all the treated sections for all projects kind of lumped into the same basket. But you can see with State Route 47 that we have higher densities about at the same field permeability test. But the one thing to remember, as I said earlier, between the other projects and the State Route 47, there's more traffic applied to the untreated surfaces prior to the sealer being applied on the State Route 47 than on the other projects. So we have traffic on the surface prior to sealer application on State Route 47. We have very little or much less of that on the other projects. And I think that's what was causing, which was making State Route 47 look different in terms of making different comparisons between our different test results, like field permeability, density, texture depth, and some of the others. So I think that's the cause, but I don't think it affected our end conclusions right now, and I'll get into those in just a little bit later. This shows the skid values over time. Remember, that's only over about a 30-day period. Thing I wanted to show here is that, remember the average application, residual application rate? That's shown on the x-axis, and then the y-axis is simply the percent, percent of the control section. So we took the skid value for the control section and then looked at what the skid value was on the treated sections in terms of a percent of that value. And you can see that there's a general relationship. The higher the residual application rate, a greater decrease in the percent of the control section skid value. And that was generally on each project that we saw. Okay? Okay. So differences between the control and treated sections in terms of the ODOT PCR values. And I broke this into two. First of all, the last two surveys, the report shows all surveys together. I'm showing the last two surveys by themselves here. And what is a delta? The number of deltas or the deltas, that's just simply the difference between the PCR of the control and the PCR of the treated section, or the section that had the sealer. And so what you can see, this is the different sealers. Here's all we did was we did a paired t-test to look at the control versus the PCR for the control and the PCR for the treated sections. to see can we say that there is a statistical difference using a paired t-test between the two. If we use ODOT's distress surveys that they made with their calculated PCRs, this is the t-value and this is t-critical at a 99% or an alpha of 0.01. And you can see that using that, there is no difference between the distress surveys, between the control and each of the individual sealers. If we look at the LTPP, though, we now start seeing a little bit of difference between the control and the PCR of the treated sections. And again, the t-value, we calculate the critical t-value for the pair t-test. And now we can see two of the sealers did make a difference. The replay showed a difference in the Reclamite, where we can say statistically we see there's a difference between the control as well as the treated sections for those two. So done by a paired t-test. This now shows the average bias, and I'll use this later on, but this is the average bias between the PCR of the treated and PCR of the control section, okay? So this is the average bias for the bio-restore was about 1.1. The average bias on the replay, a little bit higher, but not much, 1.2. And then the Reclamite was the average bias of a 2.2. That's 2.2 in terms of a PCR value. For example, if our PCR for the bio-restore was 80, the PCR, or the control, the PCR on the average for the bio-restore test sections was 81.1. And conversely, for the Reclamite, if the average PCR for the control was 80, then the average PCR for the Reclamite was 82.2. So that's just an average bias between the two that we calculated. Now this shows the PCR bias of the treated minus the control sections. So we're taking the PCR of the treated, subtracting it from the PCR of the control sections. And this shows as a function of the y-axis is the average sealer application, the residual sealer application rate, and then the average or the average bias between the treated and control. And you can see that the greater on the average, the greater the application rate, the bigger the bias. So, so what we did was we took all the PCR values for the control sections as well as the treated sections, and we went through and used a standard equation or standard relationship that's in the report that we use to calculate or determine how PCR is going to change over time using actual test data, at least at the beginning. So basically this just shows a regression of PCR values of the control section along the y-axis versus time. And this just shows the variability in the data. And then so we took that one step and we did the same thing with the treated sections on the average. And this just shows the two that had the major differences. And this is the predicted is in the dashed line for the untreated or controlled section. The solid line is on the average predicted for the Reclamite treated sections. And you can see in the report we used the PCR value of 75 to initially define what the differences was. So the difference is about, makes about a year in difference of if we were to rehabilitate at 7 or do something to the pavement at 70, a PCR of 75 on the average, then what that means is that the Reclamite, we wouldn't have to do it on the Reclamite section until about a year later. But this is at year 7 and 8, and obviously all our data are only within the first 4 years. So we're projecting out a little. And I'll come back to that in terms of a recommendation that's in the report down the road. I'm going to go through a couple of observations for the, and then I'll end with our recommendations and findings in a summary form. But there are some things that we saw in 2016. This shows we were on site, and initially it had rained, or initially it rained the night before or so. And of course, we couldn't do any of our testing, so that upset us. But then on the positive side, because we had to wait, on a positive side, it showed us a difference for some of the surfaces between the treated and untreated. And this is on 292 location B, up on northeast or north of East Liberty. This is the transition area, the untreated area. And when Reclamite put out theirs, they had that paper they put down, so there was a definite transition, and we're still seeing that definite transition because that surface, how much it's drying out faster, I don't know, but the surface is drier relative to the adjacent section or transition that had no sealer applied to the surface, okay? So the surfaces appear to be drying at different rates. The other thing that we saw for all of the Reclamite sections, you can see here, this is on State Route 47, and this was true for all the test sections, on each of the, not all test sections, all projects. And you can see where that paper was laid out, and there's a very distinct difference in the color. Really, the Reclamite sections were really pretty easy to find, or easier to find, because of the color difference. You could still see that the section, the treated section, had a different color to it. There was, on the other treated sections, the ones with bio-restore as well as replay, I don't want to say that there was no difference in the colors between the untreated transition section as well as the treated sections, but it was definitely much more difficult to distinguish. And that may be that they didn't have, they just started spraying or so, and whether that had a difference, I don't know. But for these, there was a definite difference in transition that you could still see for all sections, even, or all projects, even 4 years after performance. The other item I want to point out is that this is also on State Route 47. This is one of the longitudinal cracks, very minor hairline, but this is the untreated, and you can see the crack here, and this is the treated section. When it went to that edge, basically, you didn't see the crack going into the treated section of the Reclamite treated surface. After we saw this, we went back to some of the other sections and other projects to see, could we find a crack in the adjacent section and whether it was still going into the treated section. And we really, we didn't find any. But I'm not saying that there is no cracking in the Reclamite section, because there is. Okay, but just this was kind of a unique observation that the crack could be observed, the hairline crack could be observed in the untreated. When it went in the treated section, the crack wasn't there. And maybe below the surface, I don't know, because we didn't do any cores or anything like that. So it may be there below the surface, but you're not seeing it at the surface. Okay, so getting into now the life cycle cost, and I'm going to be ending in about another 5 minutes. Okay. So our life cycle cost analysis, we did an equivalent annual pavement cost analysis where we calculated equivalent annual pavement cost, and we went through FHWA's typical procedure that they calculate equivalent annual cost, and we calculated that for, let's say, the average. For the control sections, for an average, and then using that difference for the Reclamite sections, because it was a 2.2 difference in PCR, which translated into 1 year service life. For the replay, it was a 1.1 difference in PCR, which translates into a half a year additional service life. So for these, we used a 1 year increase in service life, and then a half a year's increase in service life. So if you use the control sections, let's say on the average, our equivalent, total equivalent annual pavement cost, or let's say $50,000 per lane mile or so, or I think that's per 2 lane miles, because we generally had 2 lanes on our analysis. And the equivalent annual cost, well, I should say what this is what additional cost from the cost of applying the sealers, the cost in terms of applying the sealers do we start to exceed our equivalent annual cost for not doing any sealing, our control sections? And so for the control, it's 50. So if our sealer for a half a year increase, half a year increase in the service life, if the sealer costs less than about, I think I used 15,000, around 15,000 or less, then it would be cost effective. If it's more than about 15,000, it would not be cost effective. If we look at a year additional service life, then we would see that if the cost for applying the sealer is 30,000 or less, or about 30,000 or less, then it's cost effective. If applying the sealer costs more than 30,000, then it's not cost effective. That's what the equivalent, the life cycle cost analysis using equivalent annual pavement cost, and the results from the PCR, that's what that would tell you, or that's what that told us. Okay. Okay, so quickly our findings. Basically, I'm going to go through these kind of individual. They're all in the report. There is no difference in rut depths. I know some agencies, if you apply some of these sealers, penetrating sealers, there was a concern about increased rut depths. On any of the sections, any of the projects, we didn't see any increase in rut depths, and we saw the rut depths were all very minor. Probably good construction practice and good mixed design practice for those. So no increase in rutting, difference in rutting between control and treated sections. There was less raffling exhibited on the treated sections in general. But again, remember I said that there wasn't a lot of raveling, and that raveling was very localized to specific project. 3, there was slightly less, and I emphasize the word slightly less, transverse cracking exhibited on the treated sections for all the projects. There was also slightly less longitudinal cracking exhibited on all the treated surfaces. We didn't see any statistical difference on number 5 in PCR value between the control and treated sections in terms of using the Ohio Distress Survey procedures and their calculated PCR values. We did see a slight statistical difference using a paired t-test in PCR value between the control and treated surfaces using the long-term pavement distress identification manual. And for a 2-point difference in PCR, we expected was going to translate into about a 1-year increase in service life at a PCR of 75. Okay, all of our PCRs are higher than that right now, but we use an initial PCR of 75 to look at what the extrapolated values would be. And a 1-point difference in PCR is only a half a year increase in service life. Okay. So this is the continue with the findings. This is the average residual rate of the sealers. The percent of sections below a skid number of 35 using the rib tire. Where that I didn't mention that earlier. Where the 35 came from, that's predominantly the median value used by agencies that have a skid number criteria on their roadways. They vary, they go from in the high 20s or 30s all the way up to about 40 or 45. Kind of 35 is in the median or mid-range. And since ODOT didn't have a criteria on skid, I just used what has been reported and used on the average by other agencies. And so you can see that as the residual appellation rate increases, kind of what we would expect from our data that was measured by the department, the percent of sections below a skid number of 35 increases, the higher the application rate. Conversely, in terms of a better, the average bias between the PCR treated and controlled section, we see, i.e. less distress, higher PCI value with the higher residual application rate. But these are the average application rates that were used by the individual suppliers, which were initially determined not based on the experience itself, but I think between coordination between the supplier and District 7. I'm not sure how those rates were evaluated or determined, but that's just the average between each of the individual projects. So in conclusion, the objective of our study, to answer the question, are penetrating sealers cost effective? It depends on which procedure we're using. If it's the ODOT distress survey procedure, we would have to say no. If it's based on the LTAP distress survey procedures, at this we would say yes. Realizing though we're extrapolating into the future from 4 to about 7 to 8 years. So with that, our recommendations are to the department was they should continue to monitor those sections like on an every other year basis and look and see what the distresses are doing and what the PCR is doing over time. Our suggestion is continue to use both procedures, ODOT as well as the long-term pavement distress identification manual, and then would continue to use the sand patch test and look and see how those are changing over time. And because our last survey, we're starting to see pretty good increases in the macro depth or the texture depth, but we would recommend discontinuing use of the water-based field permeability test because of its variability. So with that, that's the end of the presentation, and I'll take any questions.
Was the PCR and the individual test sections rated before the overlay was done?
Let me see. It's a very good question. I don't know if we actually determined the PCR based on the distresses, or I shouldn't say distresses, based on some of the defects we identified prior. But there, in terms of measuring a distress, at the time of right before the sealer application, there was basically no distress whatsoever other than US 40 that had a few reflection cracks.
I'm talking actually before the resurfacing, when on the
Oh,
pavement.
yes, there was. And that is shown in the report.
Okay.
Eric sent it to me.
Yeah, it was basically a uniform PCR section. There wasn't any big differences in condition along any of these routes prior to the overlay.
Yeah, Harold, did you have the opportunity to check the asphalt bituminous content in the surface before and after treatment with the various sealers?
Question was, did we check the asphalt content of the asphalt wearing surface before and after treatment? And the answer to that is no. The percent asphalt that I showed in the graph or in one of the tables, and that's in the report, those are based on the data that we got from the mixed design records we got from ODOT, as well as the quality control or assurance records we got from ODOT. So we did not go back and do any extractions or burn off the asphalt to measure the asphalt content of any of the sections.
Yeah.
Eric, do you want to?
Can you explain for us how you took LTPP individual distress data and married that into an ODOT PCR to create what you call PCR?
LTPP?
I don't really think it is PCR.
Probably not. What we did, and the question was, explain how we went through the process of using the LTPP distress data and then calculate a PCR using ODOT's procedure. And Eric's right, it's not a one-to-one relationship because they have certain items that they have like upheaval or so that's not in the distress identification manual. And so if you do a distress survey according to the long-term pavement performance, you're not going to capture everything in the same way. So what we did, there are some similarities though, like fatigue cracking, longitudinal cracking, rutting, bleeding, I think. We took the ones that were included in LTPP and that are included in the way ODOT calculates PCR. We use those exact values, but we use the factors, the weighting factors, because ODOT procedure has weighting factors that were within certain ranges, as well as in certain severities of different distresses. Wherever that value, distress value, in terms of extent and in terms of severity level, where that fell in the weighting factors as described in the ODOT procedure, those are the factors we used to calculate the PCR. And that's how we compared them.
So did you weight them differently based on less than 100? In other words, if you only had 6 of the ODOT distresses, and there were 4 ODOT distresses that weren't a one-to-one comparison, did you weight the LTPP differently to make it kind of a, kind of normalize it?
Okay. The question was, did we weight the distresses that were in ODOT's procedure but not in LTPP? And the answer to that, no. We just took the LTPP distresses as we would get them from using an LTPP distress survey, and where those fell in the interval for amount and severity using ODOT's procedure, we calculated the deduct for that specific distress and then subtracted it from the 100. So there is a difference, and we would expect there would be a difference. But that's what we did. The net result really, because a lot of the distresses that are in ODOT's procedure that are not in the LTPP procedure were really very small, minor, or even non-existent. And so it will have an effect, but I don't think the effect is very large.
You have a couple of questions.
Okay.
Okay, so the first question is, would any of these be cost effective to help with chip retention in difficult environmental conditions?
I'm going to pass on that. I don't really know. I think I assume chip retention would mean what that refers to me as seal coats, like a chip seal or a seal coats, and I would not know the answer to that question.
Okay.
Or I would not want to give an answer to that question. That they were not in our project experimental plan.
Okay, so next question. PCR projections show 3 points, 1 year increase in service life, higher on treated sections after 10 years. Based on this, can you conclude that rejuvenators can be used as an effective PM tool?
Again, what I would come back to is we used a PCR value of 75 in terms of comparing the PCRs for the treated and untreated section. And on the average, we did see, depending on the application rate, we did see an increase in service life, specifically a 1 year increase in service life on the average for the Reclamite, and about a half a year service life for the replay sections. But that's at 75. We did not project any further beyond a value of 75. The reason we used a value of 75 is ODOT in their procedure or in their framework, their pavement management framework, initially 75 triggered certain things. And so that's the reason we used initially 75. We didn't use higher values, and we didn't want to project into the future very long, because the PCR values are, they do vary. And so the further we make our projections, the greater that variability has an effect. And so we wanted to keep our projections as short as possible in our comparisons, the projections based on values of projections as short as possible. And since 75 was the initial value that initiated some actions by the department here, that's the value we used.
He asked another question. Rejuvenators are designed to address oxidation, raveling, and related distresses. ODOT's PCR compromises of distress such as rutting, potholes, all types of cracking, etc. Since rejuvenators are not designed to address the distresses, should we use a different index such as raveling?
Raveling's in the ODOT PCR category.
Yeah, raveling is part of our PCR.
Okay,
Yeah,
so if you couldn't hear, they said in the room here, raveling is part of the PCR.
It's part of the PCR calculation.
One last question that came in. Will there be further applications done to see if repetitive applications are done, say, every 4 years?
And what I would do, I guess I would divert that question back to ODOT if there's any plans to move forward on a 4-year basis, or?
Okay.
That's something we'd have to study. We don't know. If you were to just look at the first 4 years and only compare that 4 years with the cost, you'd have a hard time showing that it was cost effective. If we put another treatment down, that changes the dollar amounts that make it cost effective. That doubles the cost. It might also give us even more longevity than 1 year. We don't know, but we don't have an answer to that right now, whether we're going to extend this or not.
Harold, great presentation. Question, it goes back to the other question where they mentioned about PCR is made up of multiple components.
Right.
And it was addressed that raveling is one of those components. But if you specifically look at raveling and the impact of this material on that aspect, that individual distress, I was wondering, you say here in your results there, less raveling exhibited. And I guess I'm just wondering if that is of such significance, or I should ask you, would you like to speculate as to the significance of just that one distress and on the impact of...
I can, because I did take that's not in the report, but I did take a quick, the question was, if we just looked at raveling, would that have, and not the other distresses, would that have impacted the results? That kind of...
The extension of the life.
The extension of the life. And my response is, yes, we did look at that. That's not, I didn't summarize that in the report, but as I start, this will be pretty quick, but I want to preface my statement is we're basing our life on trigger values when ODOT would take some type of action, okay? So if we assumed that we just have raveling there, we have no fatigue cracking, no longitudinal cracking, everywhere else is zero. And so we just have, or all equal, and we only have raveling difference between the control and the treated sections. What you would see is the additional, or the raveling, the lower raveling on the average in localized areas that we did see on the treated sections, that would not trigger anything. We would not drop below the critical PCR of 75 or so. So statistically, there would be no difference. I'll come back. He's next. Go ahead.
In the report, do you show the PCR values of each individual test section and versus what the traffic is on those individual sections? So what I'm getting at is a lower traffic section that's due less of a structural stress. Is it faring better than something that's getting your typical high traffic?
Okay. Question was, is they do the lower traffic sections if they're performing worse or better than the sections that have high traffic? And I would have to say the two lower traffic sections, State Route 292, location A and B, they absolutely had the higher amounts of fatigue cracking and or longitudinal cracking in the wheel path. So the answer would be they're faring lower. They have more, quote, structural distress or load, let's say it differently, load-related distresses than certainly the State Route 47 as well as US 40. Coming back now.
The application rates for each of the vendors, the products, do you think that has anything to do with it? Were those manufactured recommendations for those application rates? If another one were to increase its application rate, would it affect its result?
Question was the application rates, how those were determined, and if the application rate of some of the other vendors or materials, if that increased, would that affect the results? And I guess what I would have to say is I'm unsure on how it might affect the results. What we showed in the report and in the presentation, that the results we measured were certainly correlated to the residual application rate. The higher the residual application rate, the longer the service life, the lower the higher the PCR, but then again, the lower the skid numbers at 30 days. So it's a trade-off there. How they were, the first part of the question, how they were determined, I do not know the answer to that question. I think that they were either established by the suppliers themselves or communications between the suppliers and District 7.
Okay, one more.
Is there any difference in density after treatment or during time check?
Yeah, the question was, is there any difference in density prior to versus after the the sealer application? And we statistically no. Statistically no.
Could you clarify, Harold, when you talk about life extension and the PCR, you're talking about the LTPP hybrided into PCR calculation, not actual ODOT collected PCR for the segment. Is that correct?
Yes, question was, were we talking about actual data collected by ODOT for the PCR? And one of the procedures, we used their actual data that Eric...
Yeah, I was referring to that. You talked about the 1 year with your projections. It appeared to me that the projections reflected the LTPP distress collection calculating a PCR value, not the ODOT collected PCR value.
That's correct. That's exactly right.
Okay.
Yeah, those were based on LTPP.
And a follow-up to that question, you showed a dollar amount of 15,000 and 30,000. That dollar amount is per 1 lane mile or 2 lane mile?
I think I used per 2 lane miles.
That's a 2 lane mile.
2 lane mile.
Cost of the sealant or rejuvenate.
Yes, and I used data that provided by ODOT in terms of construction cost for a typical overlay project and calculate what the original construction cost. And I think that, I'll check that, but I think that was for a per 2 lane or, you know, 1 in each direction over a 1 mile lane.
Okay. Is that it? All right, I want to thank you for your attendance. The final report is on our website. The information is in your packet. For those of you on the web, you have now seen where you can go and locate the final report. There's also a fact sheet there. I thank you for your attendance. For those of you in the room, I have the fact sheets, and I also have your CTVs available for those of you that wanted to.
Thank you.